Well, let's see. Put an image in your own heads first as to what you think would be the region or the volume that's created when this region is revolved. I'll just put the image down as I see it. This is the way I'd start to draw it, is I'd make what appears to be a circular top, because I know this is being revolved, it'd stay a straight wall. Something like this. This top edge is this point up here, revolved around. This bottom is flat, so we're making just a circle on the bottom, basically. So if I follow the same shape here, and hide it in the background. Now I've not dealt with the gravelly yet, but obviously taking this and revolving it gives me the can. I can then center this on some axes. And then attempt to get the feeling for, this paraboloid shape, revolved parabola, like the shape of the headlight or the shape of the radar dish coming down from the center. And so that may well just be drawn kind of like this down and back up. So you can think about paraboloid hole. Seen these dog food bowls, right, that don't tip over. That's sort of a thing, I guess. Dish in the middle and straight walls to the bottom. All right, so this region in here, again, you got kind of two ways that you could be working with this thing. If I were starting with a slice like this, the DX slice there. And over here, what am I going to see? Well, basically, I'm going to draw it as a solid in here, not hidden within the object. You would see basically the upper edge spun around, this little upper edge spun around like that. This height would then come down somewhere to the floor, and it would revolve around and sit here on the floor. I don't dare put it in the background, but there it is. All right, so think of my finger being revolved around, and we're right back in the land of shells. Some kind of a shell object. This y-axis running up through the center. In this particular case, they all are down at the index top. You can see and explain that. Big issue is that you realize the object that's created once it's spun, and you have a sense of what its dimensions are. Again, thinking of a typical thickness, height, and radius. You have the general notion of volume being 2 pi r ht. When we compare what we have to this general sort of framework, we see that the thickness is a dx. So I can therefore infer that a differential volume of one of these little shells is 2 pi r h dx. All right, then we can start building the integral that will add up the shells, from down here at 0 to the one that fits in right up to 2. Right, so we say, all right, then the volume is the integral of that 2 pi r h dx, and you start replacing the r and the h. Obviously, I could have done that a step before or whatever. example, when, well, we go back to probably the flat picture, you know, fastening an XY coordinate to the curve. When I start asking, you know, like, what is the radius term? What would that be in this picture?
That would be
That'd be the same as x, right? That would be this distance in here. That would be the r, that's the same as the x coordinate. So I start replacing 2 pi, and then I have an x. Ask what is the height. Hopefully you see the height dimension as being this one in here. But that's again what the same as the y coordinate. So replace the height with a y, and we've got the x.
So can we just replace with x squared?
Oh, absolutely. I'm just trying to be real stepwise here. Certainly that's the next thing to do is to know that this is a dx, so the y has to be converted, which is easy in this case. So yeah, convert the y over, and then we have that integral, from 0 to 2 if we put in the details now. Pi, 2 pi x, and then we just said the y is an x squared, so we have an x squared dx. Let's see what that is for the volume. Try to do the same as what was saying, that we had a 2 pi integral from 0 to 2 x cubed dx. So we have 2 pi x to the 4th over 4 from 0 to 2. Therefore we have pi over 2 with 2 to the 4th minus 0 to the 4th. We just cancel the 2 and the 4. Right, pi over 2. Evaluating the x to the 4th of 2 and 0. It's 16 over 2 or 8 pi cubic units. I think actually on the Dan Wiley thing, if you don't say cubic units and you just put in the answer, you're wrong. Yeah. So look for whether they really want this thing of cubic units written in, or CU maybe, I don't know what they call it. So anyhow, 8 pi, is the volume right, of this region revolves, so what would make that bowl? Be a very good bowl, I guess. Well, it would have a hole of size 0 in the bottom. I guess nothing can leak out of a hole of size 0. It's awful thin down there. I guess it just touches. Well, what if we take it and think of the slice this way that's being revolved. Right? Maybe take this lower portion off and just leave that picture. Now let me draw another picture. Again, we have the parabola out to 2 and up to 4. Revolve around the y. This time take a slice. dy slice, we might call that. But I'm going to still have that same kind of a bowl. Right? Parabolic shape coming down the center and up. But what? These things, when spun, are going to create essentially a washer in here. So thickness. Right? Take this, revolves around, and we have what's called a washer. Right? So it's basically an object that's thin. You might draw in here like that. To keep kind of in line with the idea of a disc, because this is really a big disc, take a little disc out of the center. Right? I'm going to label this as a height rather than a thickness, just to keep that pi r squared h kind of disc thing in mind. You will need a Ri and an Ro, meaning inner radius, outer radius. that's about it. When I think about what's the volume, if I think of it as a disk minus a disk, obviously then it's a pi r outer squared h minus pi r inner squared h. It's just two disks subtracted. And frankly, my wife and I were talking about this a couple of days ago. A lot of you should just think of it that way. Because in some circumstances, you write it as pi r outer squared minus r inner squared h, which is fine. A lot of you guys, once you substitute what all that stuff is in there, you do stupid algebra on differences of squares and end up with the wrong damn answer. Okay, where if you just left it as two separates, you might be better off. Okay, so I don't care which way you go, but if you're going to do algebraic stuff, make sure it's correct. I mean, it's, what can we do if you simplify this wrong in some manner? So I don't know. Either way of processing is going to be fine. But be careful of your algebra. All right, so in this sense of our problem here, where we have this thickness or what really corresponds to h in this formula called dy. All right, we can then take either form here and replace the h with a dy. Right, and say therefore the differential volume is going to be some pi r outer squared dy minus pi r inner squared dy. Again, you could write it as the difference squared if you want. Right, and then what? We know to get the full volume, we integrate to the differential volume, so volume is then an integral of pi r outer squared. And I'm going to just put these as one integral, so minus pi r inner squared dy. And then start looking at what do we have here. In this picture, we basically have this distance is r inner, right, and this distance in here is the r outer.
So,
and don't forget that thinking of, again, an xy coordinate on this, curve that is y equals x squared, which is like the upper thing. So, what do I replace, in other words? What goes in this r outer? What's this dimension?
two.
Yeah, for every slice, no matter where it is, right, it's always bounded up here at 2. So we've got a pi with a 2 squared minus, and then what the r inner is this dimension here. Again, that's why it's nice to locate a point, and what it would be the x coordinate. It would be the same as that.
So you have 2 minus x?
Either way.
Or if you just call it x?
I'm going to just leave it here as a pi with an x squared, and y here for starters. And yes, then that x squared is certainly able to be replaced with the y, so it matches the dy. Right, so I suppose we could take the pi out, integral, 4 minus y dy, and what our y's are going from here to here. Right, so 0 to 4. Amazing how they simplify down. Sometimes there's such nice little integrals. Let's see if we get that same 8 pi out of it though. So we have a pi and a 4y minus y squared over 2 from 0 to 4. So that's what pi with 4 times 4 minus 4 squared over 2 less 0, 0, get 0 for both, so that's 0. Well, that's what, 16 less half of 16, so that's 8 pi.